Thanks for joining us, Jacky.
Yeah, it's great being here. I think it's my second time here. It's always fantastic to see a packed place.
Nice, yeah. Do you want to, first question, you want to just tell us more about yourself and what Shop 3D does?
Yeah, for sure. So I'm a co-founder of Shop 3D. So we're a full service provider. We sell 3D printers primarily to sort of the professional segment. So our printers range anywhere from like $1,000 to like $20,000. The SLS being the exception, which is like quite a bit more expensive. But basically a little bit above the hobbyist market and below the industrial market, where you have giant machines and like whole rooms full of electricity and all that stuff. So that's what we do. I think we've been around for around I think almost 10 years now. So we started in Ontario and then Vancouver. We have a store in South Vancouver. So please come visit us. We're about 10 minutes east of the airport, and we have a showroom, and we have all the different technologies. We have FDM, SMS, we have SLA there, we sell formats, Bamboo, and sort of a lot of the brands that you see here, and we have scanners as well. So come check us out. But we've been in the industry for a long time. We've seen the 3D printing industry grow and change and sort of stay the same. So we've been around for a while, and at least specifically in the professional market, in that sort of small space.
Yeah, and like I'm like always at your shop, like always there picking stuff up or like looking at machines. It's actually really cool to have like a local company that you can just walk into and like see 3D printers. Because in America, apparently there are like micro centers that you can just walk into and buy machines, but we don't have that here in Canada. So yeah.
When we first started, it was like a lot of people were like, "You guys are crazy." When we started, everyone was going online businesses. They're like, "You guys want to do the opposite and start a brick and mortar store," and like, that's kind of weird. So we got a lot of resistance for that, but it kind of paid off because we really had to see printers to be able to like figure out how they work.
For sure. Yeah. Cool. And I'm sure lots of people here probably have worked with you to some degree. My first real question, I guess, is so obviously a lot has changed in the past 3 to 5 years. I would say even like 10 years ago when I first got into 3D printing, it was like terrible. I absolutely hated the experience. It would be like you bought a $1,000 hobby 3D printer and you would spend hours tweaking parameters. Fast forward to now and it's like you can pay $300 for a Bamboo Lab A1 Mini and just pull it out of the box, upload a file, hit print, and it comes out and it's perfect. So for me, as an engineer and as like a maker, it's pretty wild to see where we are now from like 3 to 5, 10 years ago. How have things changed or not changed, like you were saying earlier, from your end?
Yeah, so I mean, we've sort of seen a cycle where you have like a good 3D printer, and then something comes along that's like much better, and then sort of everyone adopts that. So we've seen a bunch of cycles now. As you mentioned, you're sort of seeing them with Bamboo, because what Bamboo brought to the table was like, hey, they're now like 3 to 5 times faster than most of the competition that was out back then, and they're reliable, right? And then, previous to that, sort of Prusa did the same thing, where they're like, hey, this is sort of like a low cost, sub $1,000-ish printer, and it's reliable. And before that, it was like Reality sort of had a stint in there as well. They're a little different. And then Ultimaker was sort of like when we first started, they were one of the first like non-janky 3D printers back then. When it was basically the only
after the wooden
Ultimaker was wooden too. My first printer was Ultimaker, the wooden one that came in the kit.
Right,
but Ultimaker was sort of Ultimaker 2 specifically was the one that was kind of like the cruiser where it took over the industry. So what I see as being the same is that we have these cycles where you have like sort of like a killer feature that kind of comes out, but the one that makes like the specific printer brand successful, out of all the hundreds of the Kickstarters and everything, is reliability. Basically, the industry needs to sort of innovate a good feature paired with being able to trust it to do that thing majority of the time. So Ultimaker brought reliability from all the jank that was there, you know, and it was reliable enough that everybody could sort of adopt it. Cruza brought the price down, and then was reliable enough that everybody could trust it. And then Bamboo is now bringing the speed, you know, and everybody can trust that speed. So like, what stays the same is reliability, and that's what I anticipate will happen in the next while as well. So I don't know what the next killer feature is, but killer feature paired with reliability that people can trust and use in their workplace is sort of the thing that I'd be looking for.
Right. Interesting. Yeah, I mean, you've been in the business for quite a long time, so it's cool that like you've seen these cycles before, and it's like, yeah, it's just something new.
I mean, it changes a lot too. There's a bunch of changes, like the questions change a lot from, you know, initially they were like, what is a 3D printer, right? And then now everybody knows what a 3D printer is. Now it's like, hey, what kind of materials do we have? You know, the questions change a lot now, and be like, hey, can this material be, you know, food safe, or, you know, can it hit a certain degree of accuracy? So that's sort of changed a lot. The ask is now evolving quite a bit, but like the baseline that we're entering into is like reliability. You know, like nothing matters if reliability is not there.
Right. Yeah. And I guess your comment about like people asking different questions. Now that you mention it, I also see it. It's like people are more focused, and I don't mean just like individuals or hobbyists. I mean also like the industry. Like the industry is much more focused on materials now, right? Like before, I think people weren't as educated about like what's PLA, what's ABS, what's the difference. Like, is it strong? And it's like if you're an engineer, you kind of hate it when people ask, "Is this thing strong?" It's like, what do you mean? Is it tough? Is it durable? Like, so I think people now are in the industry is spending much more time on like materials. And Bamboo brought speed, and now it's like speed, quality, materials, like repeatability, that kind of stuff seems to be kind of bubbling to the forefront because the hardware, the technology is like mature enough now that you can get parts out, right?
Yeah.
But it's like, what is your part good for now?
Yeah.
So.
And then sort of longer time frame too. Like before they were just prototyping, they were like, hey, we just care how good it looks initially. And now they're like, okay, like how long is it gonna last? You know, if I actually use it in the machine, like how long is it gonna last? If I put it outdoors, you know, like is UV gonna destroy it over time? So there's a lot more focus on materials on its longevity as well. So that's sort of newish.
Yeah. And it's still funny because like I was talking to a friend just before we were doing the panel, and he asked me like that exact same thing. He's like, for resins, like, can I use resins for any use product? And yeah, you can, but they're like caveats, right? But you're right, people are starting to ask this question now, and even for me in my business with Ember, like I'm doing a lot more production 3D printing now for in-use products. So the industry is definitely shifting more and more to like additive manufacturing and production. So yeah. Let's move on to the next question. How much time do I have? So I've been in this position a couple times in companies, and it's basically like if you are an engineer or manager and you want to bring a machine into your facility or your company, there's always friction, right? Like I think personally that right now with how accessible 3D printers are, it's like inexcusable for you to not have a 3D printer. But I still see day to day that like some people have trouble bringing that into companies, and you know, Shop 3D sells 3D printers, so I'm sure you have some opinions on how do you like make that process easier, like what are some problems that people have?
Yeah, I mean, what we usually see is there's usually like someone convenient, like, you know, an engineer will be like, you know, we need this because like it's going to make our work so much more efficient, and then they're usually trying to convince their boss or the manager or like whatever the structure is to be like, hey, this is going to be, you know, useful for us. So like part of our job is to sort of like, you know, let them know, hey, this will help you in this kind of way. So I think the most important part is like, if I were to boil it down, it's usually just like time. You know, like if you were to convince your boss and had like one point you give them, be like, hey, if I had a 3D printer, like how much time would I save, right? You know, just even if you like, you know, if you send a part out like minimum shipping time, even if they do it immediately, it's like 3 days, right? And you can immediately get down to one if you have a printer. So, I mean, it's sort of like a no-brainer, like you said, and I think they just need to hear that. But there's a lot of other barriers that they'll anticipate, or they'll be fearful of, like, a lot of this, like, hey, what kind of support is there? And, is this company actually stable? Like, they're going to disappear in like a year and then we're left with nothing? Or, is the stability of, like, the formalized resin, can you get resins in like a year if it's locked into it? So there's a lot of ways like that. There's also like ways about security and, like Bamboo's cloud. Sometimes they're like, ooh, we don't know if we want like cloud-based. And so there's a lot of concerns over there, but in terms of like convincing people to be like, hey, you should really adopt this, it's like, despite all those things are sort of workable, you want to save like 75% of the time. Most people are like, yeah.
Right, yeah. And I also think like a lot of times people just have to experience it before they can really understand. So it's like whatever you can do to try and make them or force them to experience it, kind of pushes that needle more. Yeah, but your comment about like SLA pushing around bad or like resin and stuff. I mean, I talk to people all the time. I talked to Colin about this just earlier today. Like, if you don't have a champion, or if you don't have somebody dedicated to like taking care of that equipment, it very quickly becomes like chaos.
Yeah.
It's like you don't have a machinist, but you have CNC machines. Who's going to run them? Who's going to clean them up, right? That kind of stuff. So, yeah, I think there are like many other things you have to think about that they don't pop into the forefront of their mind.
Yeah, we see that. It's like if there's nobody championing it, even if they do end up buying one, they'll like really use it because like they'll encounter some problem and then no one will know how to fix it. No one wants to take charge and know how to fix it, and it just basically goes unused. So we see that sometimes, unfortunately.
Yeah. All right. My next question, I think, is probably the one I'm most interested in talking about. So a couple weeks ago, the Stratus CEO gave a talk. I don't know if you heard this. Anyways, gave a talk about like the state of 3D printing and what companies need to do to like survive and be successful. And I'm talking about like 3D printer manufacturers. And to boil it down, basically, he said like if you think of a chart or a graph, like on the x-axis was like value or like specific application, and on the y-axis was cost. So, yeah, sorry, it's like mirrored, so I'm just trying to figure out, value and cost. So, Bamboo Lab, for example, is like here, where it's like the cost is very low and they serve a very general purpose. And then you have Stratus, which is like on the opposite end of the spectrum, which is like very high cost, and they're serving a very specific demographic or purpose, like high temperature, ultimate, or peak. And he was saying that historically, there's been a lot of companies that are kind of in the middle. So I would say, I'm not putting words in your mouth because like you're a reseller, but I would say Ultimaker, Raise 3D, those like $10,000 to like $20,000, even like maybe $30,000 printers, they're all kind of like in the middle. They serve like a general purpose, but they're like not cheap.
Right.
Yeah. And so the Stratus CEO is saying that in the next 3, 5, 10 years, those companies need to differentiate. They need to pick a quadrant, otherwise they're going to die. And I thought this was super interesting because I see it. And I see it, like, for example, Form Labs. They started off with Kickstarter, more in the hobby, like, makerspace down here, and now they're moving more towards this direction. So I think it's super interesting. I want to know what your thoughts are.
Yeah, I mean, I agree with that observation for sure as well. So, I mean, if you just look at the value proposition for like ways, like we're reselling all these things, but we're very open about where we think people we basically fit printers to people and their applications, so it doesn't fit under the case. Right? We're seeing less and less sort of value. If you compare like a Bamboo and Ultimaker, like the vast majority of people will get more value out of like a Bamboo because it's just like it's one-fifth the price, right? And it does mostly the same thing faster, right? And so like bamboo covers a much broader range. And yeah, and Ultimaker and Raise do have to sort of differentiate more, or they're going to get lost in the mix, or they're just going to be like too expensive to do roughly the same thing. They still have some slight advantages. So like Ultimaker is really good at doing the dual extrusion with soluble supports. Like there's no other real company that does that well-ish. The soluble is like really janky overall, especially the water soluble stuff. So Ultimaker is the only one that we've seen that like, does it like, decently well. There's still problems, but it does that best. And then Raise is like the only really like large one that can print as fast as Bamboo. So like you kind of like when people are like, hey, I need to print like helmets and stuff, right? And like you can't do a Bamboo because you're cutting that into 8 pieces, right? Like, no matter what. So
for now.
Yeah, for now. But you know, Raise is you can do it in 1 piece. So even if it's more expensive, it actually saves you the labor. That makes the choice justified. You know, if Ember comes up with a larger one that's as big as the Raise, then you know that eats in more into what we would recommend, and like it's cheaper as well. And it makes a very hard case to choose that Raise over Ember unless they do something specifically well as well. So we are seeing sort of the low value ones sort of eat up more of the sort of middle ground value. Formlabs I think has the right idea where they've sort of been like we're kind of not going to compete with like the general guys, and we're going to just be really good at making our own specific materials. So they have better materials now. Their materials are better than everything, but really fast now. So the value is increasing along with their specific applications. So I think they're doing everything right there compared to instead of Ultimaker who need to innovate faster or have some killer feature that they can't get in the something killer, they need to differentiate. So I totally agree with that sentiment.
Yeah. Like you definitely can see Formlabs kind of moving in this direction, and then the other companies are just like stagnant.
They're trying other stuff. Like Raise has like SD convert as well. Right. But they even there they have to differentiate from Formlabs. So there's a lot of thinkers, and there's like it's a hard industry to fight into.
For sure. Yeah. There's like so much hype and so much funding, but it's also like extremely competitive, right? On like the same topic, what are your opinions on? I mean, there's 2 Canadian companies that kind of like fall into that middle that I can think of, Pantheon and Mosaic. What are your opinions there? Because I know that both of those printers you either are still selling or you considered selling them at some point, but so decided not to. Or
we did rent them for a short time, Pantheon and Mosaic. I think for us specifically, I think this is just a specific Canadian or us issue where.
And sorry for context for like people who don't know, Pantheon is in Vancouver. They're doing like a high-speed FDM 3D printer, and then Mosaic is also an FDM printer manufacturer in Toronto, but they focus more on like a lights out manufacturing kind of like cell system.
Yeah, they had like a build plate changer, and then they also had like before Bamboo had that sort of switcher thing. They had the first like color changer. It was really unique where it would slice your filament, and then it would feed it into the feeder, and then you can print multi-colored parts. Basically earlier than doing that. So they were really famous for the palette, which is what that did. And then now they're focused on the array, I believe. And that's they have a basically array of printers, and then they can automatically take out and change the build plates as your production continues.
Which is actually cool to see too. Like we were talking about that graph, it's like they also are going this way, right? Which I think COVID kind of helped them because they were supposed to launch that they're just like standalone printer during COVID, and then supply chain disruptions happened, and then I think that time period in which they couldn't do anything like led them to realize that they had to go this way.
And that was cool. So those 2 companies specifically, like we did carry them for a short time or a long time for Mosaic. We didn't find a lot of success specifically because I think they were Canadian. So it's like people are coming to us to buy a printer, like they could just go to them directly because they're in Canada.
Oh, I see.
So like we're not really adding that much more value. Like for Formlabs is different. We can offer a lot of support. We ship locally and everything. So there's a little bit more value to shopping with that special 3D rather than going Formlabs direct. And then local expertise, like in the same time zone and everything. For like Pantheon, Mosaic, they're already in Canada, so all of that stuff is already localized in Canada. So while we're just sort of like, we increase their exposure and then we can sort of introduce them to our client base already. The sort of added value is not as strong if they're already in Canada. So I think that's why it sort of fizzled out. But I mean, but we carried them because like I saw really cool things with them. So Pantheon was like super fast before Bamboo was out with their speed. Pantheon was like the only ones hitting those speeds widely. So I'm like, oh, this is awesome. So we actually had a Pantheon in our showroom, like one of the super early versions for a while, and we were using it, and it's fantastic. I think because when we first started talking, they were a young company, so like they were moving very fast as young companies do, and that's harder on the reseller side. Because if anything changes, it's like if you change the price, right, from like 10K to 15K or something, like that messes up stock on our end, and like all these other problems can happen. And it's not their fault. It's like you're a small company, you gotta move fast and you gotta innovate, right? So those guys are awesome, and they do really good work and really fast. The machine is awesome as well. But in terms of structure, like it wasn't really good back then in Canada as well. And then for Mosaic, it was a similar-ish story. Like they were more structured, but because they're in Canada, it was just again the same kind of issue. Why would you shop at us when you can just go over to Mosaic for that part? But we were specifically interested in Mosaic for their high temperature printers because we didn't have a high temperature option yet. Yeah, I think I lost your point a little bit, but
you answered the question because I knew that you were evaluating those printers and like I saw them when I was at Shop 3D, but I don't think I've ever asked you like, hey, why didn't you end up carrying them? So, I think I'm actually out of time, so I'll skip a bunch of questions and I'll just end with the last question, which is, what do you see in the future for Shop 3D and what are your predictions for Additive kind of in the next 2 years?
I mean, Additive is really hard to predict. Like every time people ask me that, I'm like, I don't know what's going to happen next year. I mean, it's crazy. Like some company might come up with something that's like really awesome. Bamboo changed the industry like over like I don't know, 6 months. When they came out and just took everything by storm. And like I said, it happened again with guys. So I anticipate something will happen in which one company comes up with something that's kind of like game changery, and if it's reliable enough, I think it'll sort of take over and come by storm. Just like Bamboo Cruise Maker did. So I anticipate that cycle to happen again. But I don't know what that feature is specifically yet. So when we see it, we see the excitement about it. And I think we'll sort of know. In terms of Shop 3D, we just do what we've always done. We provide, I think we provide a very just straight up, no BS, like, hey, this will work for you, this is what it's like running the printers, and sort of honesty works in Canada, if they know if you're genuine or if it works, and we just give them straight goods, and we help support them in their printers, and I think that's just the basics. Like if you sort of master the basics, you can get pretty far ahead. So we just do the basics of having really good support, knowing our tech really well, and then being able to communicate that and help you through any kind of issues. And then on the business end, we have to find good partners and good equipment manufacturers that also support that. Because we've had some, we rep some printers that are they're hard to work with. They may be good printers, but if they don't back the support, then we can't administer the same amount of support. Then it becomes really difficult for everybody. It's then there's 3 or 4 parties trying to figure out the problem, and then it just breaks down. So we want to get really good relationships with good companies to work with, so that we can make your lives easier. That's just our goal.
Right. Yeah. Makes sense. Cool. Well, thanks so much, Jacky. Also, I didn't say in the beginning, but Jacky brought a 3D scanner, so a little handheld 3D scanner. And one of the questions I wanted to ask, but I don't have time to talk about, is how far that technology has come. So if you want to play around with the 3D scanner, go see Jacky after, and then you can play with them. So I guess we have 10 minutes for questions from the audience if anybody has questions.
Yeah, I have a question. I'm a teacher, which is kind of where this comes from. We use a lot of 3D printing, and we actually switched to fully Bamboo because it's perfect for classroom that are students in grades 8, 7, 6, whatever, as low as 7, can all use it. But one of the things we've noticed is we started generating a lot of waste this year, which is pretty hot. And we are really trying to push to be more environmentally friendly. And I'm trying to stay on track with like PLA recycling options, and I just not find any that is doable for the classroom and for the budget that school will provide. Because while the printers are $250, the recycling is so much more. So any thoughts on kind of how that's going to evolve? Because that's one of the things we really want to do. And right now we're just kind of saving all our waste.
Yeah.
Okay, so I'll repeat the question just like in case people can hear it. But basically the question is, he has a lot of bamboo lab printers for his school, and they generate a lot of waste, like PLA waste. Is there a solution for recycling the waste? I'll probably let you answer because I don't print a lot of PLAs. So.
Yeah. So we've dealt with this for like years, so this has been a recurring problem. There was one company in Ontario that I talked about. I'm like, hey, when are you guys ready? They're called ReadyTech, but basically they make a filament recycler. It has like it has a little like thing that grinds down the filament and then or your parts and then it spits it out as filament. Unfortunately, we tested it and it wasn't like quite reliable enough to use it. Like that would be my favorite solution if it really came as a great solution to support it. Unfortunately, it's not there yet from our testing. The other option is I would look into some kind of mini like molding injection molding projects. Yeah, where you can print the mold and then you can sort of like squish your waste into other things that you can use. So I think that's probably the most effective or cost-effective way of like reusing it. But unfortunately, there's no good commercial way to sort of save it. And then in terms of recycling, just you can get the we found we had a ton of the spools left over. So it's good that there's more recyclable or sort of the refill spools. Like get those so you can at least save on some waste in the spools. But yeah, unfortunately, I think the injection molding or using the scrap as something else is sort of the best way right now. And I know it's not the best case.
Yeah.
Great.
Yeah.
Cool. Any other questions?
Hey Phil, you talked about all these changes in speed and amazing advancements, but not how. How did it happen? How did you get faster? How did they? Do you know?
Just like in general,
take the bamboo labs. How did they come out of the gate with something that was so much faster than something anybody had come up with for the last 10 years?
Yeah. From my understanding, I don't build printers, but a lot of it is hardware and software firmware. So I won't get into it, but like there's a group called Boron that builds a lot of like really high-speed printers, and they actually have been designing these printers like years before Bamboo. And Bamboo basically like took their design. So that's like the hardware part of it. I'm just being honest, it's like open source, right? So that's the hardware part of it, where you have lighter gantries, you reduce your mass so you can accelerate faster. I think the more interesting part of it is like doing software and firmware to calibrate for like ringing, for like flow compensation, dynamic flow compensation, a lot of those things.
And thermal compensation.
Yeah, like a lot of those firmware, software type things coupled with hardware improvements led to the increase in speed. If you're talking about like the SLA printer, like the Formlabs machine out there, people have gone from like a single rastering laser to doing masked LCD or DLP, which is like printing one cross section at a time. And even that technology, like it's been around for a long time, and you can actually buy $300 machines that print in that fashion. But some of these companies are just taking these technological advancements and just packaging them up to like really, really dialed printers that you can buy for off the shelf, right? So it's like a combination of technological improvements, but also just making sure everything works really well out of the box.
Just integration.
Yeah, like systems engineering integration, which is really hard. Yeah, that's what I think.
Thank you.
Just just following that line of reasoning, it's not really a question, but I think there's a project where these guys are trying to make an extremely fast extruding printer, and they realized that the gantry is not the limiting step, it's the extruder itself. Instead of like a 7-way extruder that's like taking multiple filaments to like put more heat into the joint essentially, and that's a fun project to follow. And they're trying to print that little boat. What's it called? Eventually, like 1 minute or something is their goal. So if you're interested in fast printing, there's some wild people out there.
Yeah, and actually, is that Vlad?
Yeah.
Yeah. That's actually a really good point because I forgot about that, but materials is the other part of Jeff, your question about printing fast. Like materials with resin, materials with filament, right? Like with filament, you need to mix your material to have high flowability. With resin, you need to design it so that it doesn't overheat, so that you can print like cross section by cross section super fast. So there's a lot of chemistry and material science behind printing quickly as well. Great. Okay. Well, thanks again, Jacky. Let's give him a Okay, so now the panel speakers can come up. First thing is just if you guys can all introduce yourselves and also mention, where 3D printing plays a role in your job, life, or career. Just pass the mic around. It should be on.
Okay, excellent. Hi, everybody. My name is John Nakane. I'm a lifer over at UBC. So I'm a faculty member in the materials engineering department. I look after a program called Integrated Engineering, and I do a fair amount of teaching for the first year program. And a lot of what I sort of help to look after are prototyping, so getting students to think about things that they have in their heads and in their imaginations, things they have in their hearts, and actually putting them out to the real world. So sometimes with electronics, sometimes with physical things, and oftentimes with fabrication with 3D printing as part of what they put together as well. So I'm happy to share a little bit about how we big kinds of experiences we line up for our students on campus.
Thanks, John.
Hey everybody, I'm Ian Nakamoto. I'm with Forge Labs. I'm one of the partners there. We are a industrially focused additive manufacturing bureau. We will take individual hobby jobs and things like that, but we are mostly focused on I would say high-end printers and high-end materials. So our machines typically are from the $100,000 to the $500,000 range, and we're really trying to fill the niche for people who need bridge manufacturing, when you need to produce a quantity of parts in between where injection molding makes sense and where sort of prototyping falls off, and providing options for things that cannot be printed on hobbyist or prosumer machines. So very large parts, very dimensionally accurate parts, very high temperature materials, things like that. My background is actually more in art fabrication, and I wandered into this entirely by accident, and I work with lots of engineers. So it's very exciting, and I'm sure people who read me would be shocked to know that I'm being described as an expert. But happy to join all of you.
I'm sorry.
I see lots of our customers here tonight, and if I don't know you yet, please come say hi, and I'll see if I can sell you some plastic.
I'm Radu. I'm the lead design engineer at Arbutus Medical, and the company is originally spin off from UBC. It's been around for 10 years or so. Originally, the company was focused on enabling orthopedic surgery and safe tools in low resource settings in low-income countries around the world. And the last 5 years, we've actually found that there's a big need for more safe tools in departments, in health facilities in the United States. So actually in the emergency departments in the US, there's a shortage of orthopedic power and orthopedic tools to help people who have suffered trauma and to treat them before they're admitted or just treat them and discharge them. So a lot of our focus recently has been on developing tools for the US, but there's so much overlap in terms of their resource needs in a global health aspect and also in the US in these specific departments. So in terms of my role, I pretty much use 3D printing every single day. I use 3D printing for prototypes, for building demos, for surgeons to evaluate and give us feedback, and for making manufacturing jigs, for actually assembling the product, and actually most recently with Philips' help, actually building end-use devices, so we're 3D printing parts for final medical devices.
My name is Colin Schlosser. I'm mostly here in the capacity that I used to work for Rapidia, which is a local metal 3D printing startup. I spent a lot of time wrestling with tough problems, mostly material science and also sort of printer design and 3D and that kind of thing. I currently work as a research engineer at Abcellera, and we have several FDM machines that we use probably almost every day as well. It's mostly for small prototypes, sometimes models of biology, but often enclosures, cable, lots of sort of instrument support, I suppose, and sometimes manufacturing phase.
Thanks everyone. I also realized I actually didn't introduce myself. Yeah, so for those who don't know me, I'm Tsao. I'm the founder of Ember Prototypes. Ember Prototypes is a rapid prototyping product design company in Vancouver. We do a lot of different things, but basically I run a small service bureau, so I have like a formats machine, well, multiple formats machines, like a laser cutter, plasma cutter, do some metal work, and I also do mechanical, electrical, firmware design consulting for people, and we're also starting to sell our own Ember branded products that are like solving problems in the, I guess I would say like hobby level manufacturing 3D printing space, like not on humans level, but like solving some problems that I encountered running a service bureau and selling those problems. Yeah, so that's me. I did have a general question for everybody, but in the sake of time, I think I'm going to skip it because it's not that interesting, I guess. My first question is for Radu. So you and I have known each other for a while and we've like worked together a lot. And like you said, you use 3D printing a lot for MistyWest. How has, from like a product development hardware engineering perspective, how has 3D printing changed how you build hardware, how you design hardware, and also how you manufacture hardware?
Yeah, so I'd say the biggest game changer for us was SLA printing. We got our first Form 3 in 2020 or early 2020, and that kind of just changed everything that we're doing. So before that, we're relying a lot more on machining iterations of prototypes, which would take 2 weeks sometimes to get the parts back, and you find out, oh, this doesn't quite fit, or the surgeon says, oh, this doesn't really work for us, and then we'd be trying to pack in so many different design changes to that one machine iteration because it costs so much to actually do. So I'd say as soon as we started leaning into SLA printing, we were able to do changes every single day, and then we'd only do the machine prototypes maybe every month once we've had a lot of those other smaller changes. So that's been one big contributor. I'd say the other thing, how many of you have used SLA? Okay, so quite a few people are.
That's more than I thought, actually.
Yeah, I'd say. It's just the affinity and the quality of the SLA prints is so high that it's just incredible to use it as a way to engage users and surgeons. And oftentimes I find people that are not in the kind of tech or maker community, 3D printing is still such a novel thing. So they're very impressed when they get something. So we'll have a surgeon give us feedback and say, oh, I really want this part changed a little bit more, this lever could be a bit longer, and then 2 days later they get this prototype in the mail and they're just blown away by the speed of it. And it's kind of part of our secret sauce at Arbutus Medical to really listen to the user's needs, and we lean into 3D printing to show them we're listening, to show them how responsive we are to their feedback. One example is we often actually get phone calls from surgeons saying, hey, we got a patient that just came in. Our other device, and it's usually a stainless steel, like archaic thing, isn't working. Can we use your prototype? And we're like, okay, wait, no, don't put that thing on there.
Colin's face is like,
So you'd be surprised. So I think kind of showed you the power of 3D printing and where it's come, and how we can use it to really engage people and get that tactile feel and make them feel like they're interacting with their real device.
yeah, and I think like for me as an engineer too, you know, just the fact that you can iterate like 6, 10 times instead of 2 makes a huge difference. Like it's like a world of difference, right? Especially if it's a product, I guess in your case, you know, surgeons need to use it. Somebody needs to interface with it. And you know, if you're just designing a box that's just gonna sit there and collect data and whatever, it doesn't really matter. But if it needs to have user interaction, I always think the more iterations, the better, right? So, do you want to talk a bit and share a bit more about how Arbutus uses 3D printing for like, production for like, end-use products?
Yeah, totally. So this is kind of a newer area for us. We had some feedback about some challenges that surgeons were facing about 1.5 years ago. So we had a device already in the field that was being injection molded. And we found out that by making a small modification to the device, by adding these adapters to it, we could eliminate the need for a lot of other infrastructure. So it's for a traction device for pulling on your femur or your pelvis when you had a fracture. So it's pulling that those bones back in alignment. And traditionally they have to use a complex pulley system actually at the end of the bed, kind of like those World War II images of patients lying there with all these pulleys and stainless steel hardware. So we came up with a way to eliminate all of that. And the surgeons were like, this is awesome, when can we have it? And we said, okay, well maybe 4 months by the time we do injection molds and get this thing launched. And the need was so high that we started looking at other ways to make this change, and this product add-on launched earlier. And then we said, well, Formlabs has those biocompatible materials, why don't we just launch with those 3D printed adapters? So then soon enough, I can keep up with our Form 3. So then I reached out to Philip, and then he started turning his shop into a production facility. So we're 3D printing pretty much nonstop these batches of these biomed durable parts. And I think the other
I was printing like over Christmas, like over the entire holidays.
And the other benefit to that, and why we want to start looking at doing that more, is that it really de-risks molds as well. So, we got a lot of actual user feedback on those 3D printed devices, and then we're able to tweak little angles, tweak performance before committing to the molds. So there's another benefit of that.
Cool. Do you guys have any other comments about like 3D printing and like design and iterations and stuff?
I just have a quick follow-up. I'm curious, when you decided to go from machine, probably aluminum, I guess, for prototypes, maybe oh, okay, sometimes down. Okay. So I guess I assume kind of you were making metal, and then you were kind of backing off to plastic. So maybe my question is to you, but I was sort of wondering, what did you feel like you were risking or losing by making that change? Like, how come, why not make it sooner? Did you just not sort of, were your eyes not open to the the world of 3D printing, or?
My eyes were not open because of what Philip said earlier. I think the FDM printers were just so frustrating that we're wasting so much time tinkering and problem solving. And like it just, yeah. As soon as the reliable SLA printers came out and we found out about them, we actually invested in them, that was kind of the switch. And yeah, I'd say a lot of the times we're making these plastic parts out of Delrin or other higher performance plastics, and then we're able to build the SLA. But now we're actually starting to use FDM more, which is kind of interesting because of Bamboo Labs, for example, right? Because it's a lot quicker and it's a lot less maintenance, and you can use it for other simpler fixtures, and maybe even just like very early prototypes, like form fit function prototypes.
I got a question.
Robin, sit down, Robin.
Good one.
Okay, but I think because like I didn't really consider the time it would take to like ask questions after every specific. Yeah, so I think let's leave questions till the end for a Q&A, and I think I won't take questions in between. it's no time for that. Colin, I did want to make a quick comment. Like, I think part of that is also just like, if you didn't work or gain experience in a place where like you had tools, like Colin and I used to work together actually at the Genome Science Center where Robin works, and we had like water jets, 3D printers, like so many tools, right? So I think if you weren't from that place where like you had all these tools at your disposal, it's like hard to just think of it and jump into it. There's maybe that, and there's also maybe like the company you're working at just doesn't have any tools, and now you have to like convince, like what Jack and I were talking about earlier, you have to convince management to like then buy a tool, right? Which I'm sure probably was painful for you to like convince them to buy Form 3. So yeah.
I think it's the reputational damage is sort of interesting too, like the lag that was added because you had bad experiences to begin with. And I think also there's like almost a marketing angle because at some point the materials got big enough to compete with Delrin, right? And I think even at SLA for a while, the material was quite middle. So it was like, you know, it's not really in that same category. So
Yeah, that's
probably a bunch of things there.
Yeah, that's a really good point. And like, this will be like my last comment on this, but your response about like materials is super accurate because you know, Radu's traction device needs really, really high stiffness, and it just so happens that there's like rigid 10K, which happens to be very, very stiff and like as close to aluminum as possible, which is like close enough, right? Things.
Can I also just add one thing to that? I think there really was a shift in terms of the ease of use of some of the software interfaces for slicing, because there was, like, I think for a long time that was something that Stratasys had very strongly, something like GrabCAD, and then Formlabs, all of the slicers that they built are also really easy to use. So those two things are the things that I think make them, and Bamboo, although that's not necessarily an original slicer, but all of these firms have very easy to use slicers, which made the use of it in these kinds of settings all of a sudden more viable. Whereas if you were looking at some of the older industrial systems and even some of the present industrial systems, the interface and the software controls are very, very technical and kind of brutal. And then the early like hobbies. I started with Stratasys.
What a place to start! Wow.
By accident. The slicers are kind of challenging, and your rate of failure was so high that you weren't necessarily making a good decision by trying to bring that into your facility to try to use it for prototyping. You were maybe just wasting a bunch of time and then getting yelled at for wasting a bunch of time.
Totally. Yeah.
We're dying inside for wasting so much time.
Yeah, those are all good points. John, do you have any comment? It's okay, you know.
Yeah, I'll
Yeah.
follow.
Okay. Cool. Well, yeah, I'll move on to the next question. John, this is a question for you. I would say that for all of 3D printing's benefits, I think also it is kind of like tunnel vision. I don't know, this is just my opinion. Maybe I'm totally wrong. Maybe I'm sounding a bit old. But, you know, I think it's maybe tunnel visioning the young generation of engineers to just kind of look at all problems as a nail and 3D printers as a hammer. What are your thoughts on that, and like, what are you doing, or what can we do to like, prevent that from happening?
Sure. So I think it's a combination of the things that you were talking about right now about being in an environment where you get a chance to see all these different kinds of fabrication tools, and you get a chance to have repetitions on these. You call them iterations in that same thing. So for us, a little bit of history. So I like I said, I work at UBC. We have a course called Introduction to Engineering for our first year students. We bring them all in. We see them for the whole year. They work on projects of different kinds. The first year we started this course, 2015, and maybe the second year, we had like a computer-aided design module, a CAD one. And it was okay. The students got a little bit of experience, and they put together designs and got to a certain point. But it felt like they were missing out on something. And the part that they were missing out on was designing a thing and then actually seeing what the thing looked like in person, or what that actually do to help their thought process for the next thing that they would make. So starting around 2017, we tried to have them have some intro CAD things before the module, which led us to try to offer up some mini project for them. The mini project we came up with was something fun. We wanted them to all make their own keychain. So it's like a certain size, and it has to be, you can't make it much bigger, but otherwise, here's some tutorials, go to town, come up with something interesting. And I think we found something where people who are really experienced could showcase what they could do. People who it's their first experience, they would just try and experiment a little bit, see what they were comfortable with. And then we took all the designs and actually went and 3D printed all of them, all 800 of them. So for a few years, we used a company called Shapeways. They got bought out a while ago, so I was introduced to Ian. And so this is the first time we actually met in person, but the email chains between myself and Ian are just like, and it was fantastic. It really has been. And so for students who have designed a thing, they ship it out, they're excited, they come back. Some of them, very happy with what they get. Other students, very sad. But they learn from the sadness. They work in groups of like 5 or 6. You learn from sadness. But within your group of 5 or 6 students, you get a chance to have a look and see what designs worked, what designs failed, and everyone learns. And everyone tries to learn from that experience, from that one tool. Now, can we get a chance for them to see all the tools that are around? There's lots of water jet cutters and a few laser cutters on campus, a lot of shops that people will work in. In first year, we can't quite do that, but as students go on to different programs, for my own home base, we got people like Charles and others who are training students in depth for how to make better use of those tools and make more appropriate decisions. But I think even that first experience teaches them that 3D printing has its own limitations. So it's not the bag of hammers that you can use for everything.
Okay.
It's just it gives them a few more points of insight.
Right. Yeah. Okay. Yeah. And like your comment about before you would only have CAD, and now you want to like have them make something and see it in their hands. Me as an engineer, I'm a very hands-on type of learner. Like I don't do that well just by like looking at a textbook and just working it and being like, I know how to do this now, right? I need to like make things and see it. Now that you've introduced this into your course, have you noticed that some engineers or some young students who historically maybe didn't do so well in school are doing a bit better now because they have the ability to 3D print things and like more easily kind of like fabricate an actual object?
At times, I think what you had said about sort of maybe some limitations that can come out. There's the ability to visualize and then put it into a format to get 3D printed. That's a skill, and for some it takes a while to understand that you can't just present an idea. The idea actually has to have dimensions. It has to have size. It has to fit with other things as well. There's a level of complexity that comes with it. That's hard to do. I think this helps them get a little bit further along. Right. So it doesn't necessarily solve the problem. Are there wastes? So the person or the teacher who had mentioned all the extra waste, I feel you, man. So we absolutely have that environment, but it's a trade-off, right? How constrained a line do you give students the experience versus how much freedom do you give them to figure? You want to have in a learning environment just enough room for people to still experiment, learn, and just as importantly, learn from others as well. So if they can learn from the folks that else.
Right. Thanks, John. Radu and Colin, you guys work with other engineers and maybe have junior engineers that both of you mentor. Is this like possible false fear of mine where like young engineers are just like not learning how to design actual parts true? Or I don't know if you guys want to share that, but
I work with, it's not true, I would say. And I think there is, even people who are well experienced in prototyping, there is, it is accessible and fast, and it doesn't take any of your time. There is kind of an inherent laziness where if you can print it, you might do that. So you might, like, I think all of us get sort of steer ourselves to that as a solution. I think partly because it's sort of no hands-on time. It's something that can run in the background while you're doing things. So, but I think I found that actually the engineers, Jacky Wan is one that came out integrated engineering. I think they're pretty well rounded because they ultimately the projects they work on are complicated enough and have demands that are complicated enough that you couldn't just 3D print a way to success then. And I think even with nice finish and fairly accurate SLA parts, there are still limitations that make that true. I guess it'll be interesting to see as things get better and more accessible whether that becomes more true, whether people sort of lose touch with some of the other ways that you kind of quickly manufacture things to high accuracy. So I think for now it seems okay.
That's nice to know. Yeah, Radu?
I agree. I think I'm pretty impressed with the co-op students or the recent grads that we've hired in the past, especially from where I graduated in 2011, and I'd say I didn't really have that much like CAD and hands-on skills of how to convert ideas into something tangible. And I think that because of the programs, like John's actually graduated from an integrated engineering, and even back then we were still maybe just slowly learning into how to utilize these things and make it more, tangible. So I think the recent grads I'm finding are more equipped, and I think that it's the problem solving that takes a bit of experience, but it's nice when they have some of the base skills so they can jump right into the roles, right into the tasks. So if they already know how to use CAD, if they already know how to use a 3D printer, that's already a fantastic start compared to other peers that maybe have not.
Right, yeah. Well, that's like actually really nice to hear. I don't know if it's just like some irrational fear of mine, but Ian, I saw you were like nodding your head.
I think there's some interesting things happening there, and maybe I can talk a little bit more shit because I'm not talking about anybody who works for me or with me or who's in my program. But actually, I was thinking about this one because I go off on this one all the time, because occasionally we see, more than occasionally, we see people submit designs that are meant for mass production, and they have locked themselves into a corner because they have designed something that can only be 3D printed. And to me, I'm not personally complaining about that, but it does seem to me like sometimes I'll see things where I look at it and I go, this could have been machined for less money, but it would have required a different design skill set. But the flip side of that, and I think there's a generational element to this to a degree, where there's people who come from machining who are submitting things to be printed where it's still cheaper to print it, but they're not optimizing it for printing. So it's still cheaper to print it than to machine it, but they could reduce the material. They could make the part lighter, or it's over tolerance. So now I have a 3D printed part where we have to ream out all of the through holes, or we have to do a ton of optimization to the parts where we're printing, inspecting, discarding a certain number because their tolerances are in the realm of machined tolerances. So they're not quite used to the inherently looser tolerances of 3D printing. And then on the other side of it's the hypothetical zoomer, Prusa owning, a child that only knows how to print something and has never walked into a machine shop. But I actually find that there's increasingly a large number of people who have skills in both camps, where they are taking advantage of the design freedom that 3D printing offers, and they're using them alongside machine parts in functional applications. So generally speaking, I think it's been a good thing. I think it's been a good thing in terms of, as more and more manufacturing has done overseas, there's now this area where North American engineers can excel at something where it's very rapid and it's a sort of a unique skill set, but there are sort of humorous things happening
on both sides.
On both sides of the spectrum, yeah.
That's funny.
So
Yeah, I think this is one of those like philosophical debates too, in terms of how much can you learn on the job versus how much students can really be prepared for the real world, or like the applied world. Because I humbly, like I only really learned about injection molding truly 5 years ago, and I was dealing with an injection molding supplier, and I just felt like such a noob, and I was 10 years into my career and 3D printing these things, and they're just saying, oh, well, you can't have that undercut, and so it's sort of, I think, on the teaching side, there's only so much we can do to actually build that foundation, and then the rest of it, it's like, yeah, maybe they need to mess up a few parts. I think we've all messed up enough parts, and that's the only way we really learn, and scrap a few $1,000s on a prototype just because you didn't put the right feature in.
Yeah, I think that's a really good point. Yeah. Any other?
I also really like to learn from sadness. I would like that on a poster, like a t-shirt or something.
Find a way to put that into your curriculum. Okay. Next question is for Colin, so I will mix up the order. So you worked at Rapidia for quite a while. Yeah, and were you one of the early employees too, or?
I think I was number 9 or 10 or something like that.
Okay, yeah, so fairly early. The metal printing space is really interesting. Like I think that's like a perfect description. There's like so much hype around it. There's so much funding. There's a lot of competition. It's really hard. At a very high level, like what are some things that you've taken away from those like 4 or 5 years at Rapidia?
So it's probably good to kind of segment it into 2 categories right from the start. On the high end, you have laser melting machines, and I would say those have been reasonably successful. Like I was just talking to Ian, who runs one. I think service bureaus are making parts, and I think for relatively high end applications like in aerospace, they have actually been pretty successful. So Rapidia was sort of in the what you would call sort of lower end metal market. This is still sort of like $150,000, let's say approximately per machine. And I think you saw a big wave of excitement for that kind of machine, where you might run it as a machine shop or a prototyping facility, or a university lab or that kind of thing.
And can you just like for the audience, can you just describe like what the difference between Rapidia's tech was?
Sure.
Like
and on most of the machines that exist in that sort of, we call it lower end for metal, right? Because it's lower end than these laser machines typically. Most of them rely on sintering as a secondary step. So usually at a lower temperature, somehow you're organizing powdered metal into a kind of preformed shape, and then you're putting that in a furnace, much like you would sinter a ceramic body. That part goes from sort of a loosely held together metal powder to a continuous metal part. And so, companies like Desktop Metal and Markforged, many of you would have heard of these companies. Rapidia existed in the same space. We sort of formed the object in using an FDM style machine, and then we also developed a furnace to sinter the part. Okay. So why haven't you seen any penetrations of those machines? And I think the sort of macro trend in 3D printing that Jacky was talking about, reliability being like one of the really big drivers of adoption. I think machines in that space suffered from sort of what you would kind of broadly categorize reliability issues. And I think that the printing aspect is one thing, but you have this second step, which is sintering the part. And it's sort of, if anyone's worked on ceramics at all before, that gives you a taste. Like it's a bit of an unpredictable process. And it also is this sort of additional constraint that drives your design, and it can be quite challenging to go from idea to part quickly in a process like that. And I think that a lot of those companies have run against that being a big challenge. So I think, in short, kind of reliability. I think there's also an element where it's still a bit too expensive for the kinds of people who might be interested in taking a flyer for something that's sort of newer. So I think that's the second thing. And it's simply hard to make a very good furnace for the price that I think that maybe people would want to buy that style of machine. So.
Right, yeah. And let alone like space or power requirements or whatever.
Yeah, and Rapidia did quite well to design those, and the machine that we worked on, is actually quite good that way. Now you still have sort of metal powder, but in this case it's backbone, so you're kind of working around that kind of safety requirement as well.
Yeah.
So, the companies that existed actually did do pretty well to work around that constraint, but still, I think the application areas that they found were sort of too small.
Right, yeah, because I mean, people in that space where they're like extruding layer by layer, like metal paste or metal filament or whatever, it's like the surface finish isn't as great as like a laser melting or sintering machine. And these companies that usually are metal 3D printing typically have a lot of money, right? So they kind of just go straight to the good stuff, like the stuff that IGEN has. as
Yeah,
opposed to, like,
it's a complicated story, but also the existence of service bureaus means that you don't necessarily need to bring a machine in-house, right? Service bureaus can make these parts for you, so there's the added sort of complication when you actually bring that machine in-house versus having a service bureau who's ready to accept the bigger capital cost because they have a bunch of customers that they can serve.
Yeah. Do you think it'll ever get to a point where it is more, because like, I mean, what you're describing is basically where FDM and SLA was, like, let's say 10 years ago, right?
Yep.
But now it's so cheap that it makes sense to just bring it in-house instead of working with a service bureau sometimes.
I think it's possible. There's a lot of hard technical problems to solve there. Yeah.
Okay, I'll let you say something.
I'm the principal engineer of Rapidia, working on any kind of product development that still exists, and it does. But certainly lowering the cost of the furnace, because metal powder and the paste mixing is quite low cost. The only real IP on the printer is the extruder heads and the pressurization system. But taking that furnace and putting it into a consumer's house is the biggest drawback, because power requirements for the current system are not incredibly high. You can run it on a dryer plug, but taking, if you wanted 3 or 4 of those in your facility to run many parts, it starts adding non-linearly. So making a smaller, cheaper, more accessible furnace that has a very clean sintering would be looking forward to that.
I also want to say that the furnace that you guys have is really good in that if you look at any of the other systems that use that kind of second furnace step, the energy costs to run those furnaces are way higher and actually make it prohibitive, even from a service bureau perspective. You look at that and go, the way that you guys built that furnace is very, very clever.
And that's actually,
I don't know the technical details.
and that's actually a really good point, Alan, because for a period of time, I think both of you know this, but I was considering getting a Rapidia 3D printer, or I've just been thinking about metal, like the low end of metal 3D printing in general, but the part that always is a challenge is the furnace or the sintering part. Like, anybody can buy metal filament and print it on a FDM 3D printer, but then where do you go to sinter it? Like, I go to you guys, or I go to Jacky and like, you ship it somewhere.
Well, we sell the metal filament.
Right.
The ESF metal filament, and like the solution for that is like similar to and there's like one place that does it. They have a specific.
There's like a schedule or something,
Yeah,
like.
and there's added. Wikipedia doesn't have like a defining process. But this one does, and it's super prohibitive for like basically anything.
Yeah, and like, even though the service exists, it kind of defeats the like rapid prototyping iteration like mantra, right? Because it's like, I print this part in-house, but now I have to wait a week or 2 weeks to get it back. It just doesn't really make sense. Or 3 weeks. Okay, wow, it's even worse. Yeah. So definitely think that's like, if you guys can solve that, then yeah, that would be huge. Last question about the metal space. So you mentioned Desktop Metal. There are like some other companies out there. Desktop Metal is not doing that great. Like, yeah, why are some companies doing better than others in this space? Is it just super competitive? Is it what you're talking about with like the difference in the entry level versus like laser sintering? Like, yeah, what's the?
Yeah, I think that, like I was saying before, that category of machine didn't sort of land in an application area that really sort of gave it purpose, or like was enough to sustain all of the investment, all of the work on those machines. So I think maybe at a lower cost, that's interesting, and like we discussed, it's pretty tricky to take that route lower cost. It's not impossible, but you could, like Desktop Metal and Markforged, they weren't really interested in doing that. Instead, Desktop Metal got into binder jetting, which is a similar technology, but it's a different way of forming the part, but it still needs to be sintered. And so, I don't know if I have a really concise way of putting it, like why they succeeded versus failed, but I think ultimately the kind of idea that there could exist like a $200,000 machine that produces FDM finished parts with the added sort of complexity of this sintering process, making it low, like reducing the reliability and making it more challenging for users to kind of get their part. I think that theory was tested and sort of failed basically.
Right.
Several different players.
Right. Yeah. It's almost, I don't know, I almost feel like the tech is interesting and it's cool, but there isn't really like the right market fit or like business prop for that area specifically, right? Yeah.
I think, the way that I thought about it when I was prepared, like, we use a large prototype, and a lot of parts out there are made by casting and finishing machining. And I think the way I was thinking about it at Rapidia was, this is a great way to make something quickly that sort of is almost like a large part. In a sense, it's the 3D version where you can make something that's near net that you can then go finish machine and pretty quickly have a relatively complicated part, arbitrary angles and potentially back shapes and weight and that kind of thing. I think the machines are just not quite there to deliver that promise. And part of it is this reliability story where just tying all those pieces together is tricky.
Yeah, that makes sense. Any comments from you guys? I mean, Ian, you probably do some metal 3D printing.
What I would say is that the sweet spot for metal tends to be parts that are so complicated that there's no other way to make them geometrically. So that really benefits laser and powder-based processes because the constraints on geometry are the most minimal because they're never going to be cheaper than a machined part. So if you can send it to China and get something CNC for almost impossibly low prices, that's very appealing. The only reason to consider it is when you're starting to design things that are so complex. In my opinion, that's what we tend to see is stuff that's just complexity exceeds any other way to make it. And very often my response to people looking at the metal parts, if I feel like somebody's, let's not say about to waste my time, but insert polite way to say that instead, is there another way for you to make this part? Oh, there is? Do that. Because it's going to be cheaper.
Yeah, and I think like, I've thought about metal printing for so long, and I think there's, in my entire career, there's only one time when we actually metal 3D printed something, and it wasn't even that interesting. It was just like a block with a bunch of holes in it.
Yeah, so like, you mentioned that it's only these really complex parts, but don't forget plastic printing exists, so it's not only does it have to be really complicated, it has to either be extra high stiffness or hardness or high temperature. So right, you're sort of reducing the applications of it.
Yeah. Okay, let's go on to the next question because I think I'm actually running a bit behind, but it's too interesting. Ian, this question's for you. I mean, we've been talking about metal 3D printing, but like before that, we had talked a lot about like bamboo labs, worm labs, and you run Stratus machines that are like $500,000, $1 million. What is like the biggest difference from your perspective, like as a user, between these two types of machines?
So I would say that when I started working 3D printing, I started inside, we were sort of semi-incubated in a complicated way by a Stratus reseller. So the first 3D printer I ever touched was an industrial system. So when I started using, I guess, hobbyist or prosumer systems, I was like, wow, this is really hard. I'm used to having my hands held. But I will say that the differences between the industrial machines and the hobbyist or prosumer machines in certain categories have narrowed or disappeared, but in other areas they're still very distinct. So I would say there's a few areas where the big machines still have a lot of value. We can talk about it in terms of categories. So let's start with FDM. If you compared a Prusa to any Stratus machine, any of the Fortis machines, they were slower. They can print a very limited number of materials, and they're basically unenclosed. The real upgrade of the bamboos, and I guess the Vorons did that as well, the Core XY machines, was that they can go really fast. The Stratus machines were always that fast, so for a very long time, if you wanted to do production runs in FDM and you were doing it on a hobbyist machine, you needed to have an enormous fleet of them. That gap is narrowing a little bit. Where I still see the Stratus machines, and we have a ton of them and they run basically non-stop, is in the high temperature materials. The thing about those machines is that it isn't really possible, in my opinion, and I think this sort of gets into some of the things that people were talking about with the metal, which is that there are certain things that to implement just cost too much money in terms of building it out to make it a prosumer or hobby level machine. Like the heaters in the Fortis machines are like $5,000 heaters from the supplier. Like, I mean, maybe if you made as many of those formats, if you get that down to 500, I don't know. But the machines weigh like 2,000 pounds. They've got fully enclosed ovens. The heads and the head is fully outside of the oven with just the two extruders poking through like a flexible bellow system at the top. All those patents are expiring, by the way, so I'm sure we're going to see innovation in that space and people knocking it off. Actually, already there are people cloning those machines. But the thing that
They're super loud.
I mean, I can't quite hear you. I actually have seen there are companies out there building what are basically Stratus clones that are so close that you can use Stratus tips in them, things like that, now that the patents are expiring. But the thing that's interesting is they're not really that much cheaper, because when you start putting in motors that big and heaters that big and build platforms that big, the costs are just high and they're not building as many of them as Stratus is. But big builds, high temperature, you can print PKK, you can print Ultim, you can print solid blocks of materials. If you want to print a chunk of ABS that's this big, 100% infill, it'll do that no problem. You want soluble support that has no defects in it, it'll do that no problem. They have very good thermal management, they're very robust, you can run them every day and not have any build failures. Until you get one insane build failure where your head is covered in Ultim and you have to buy your head. That was not.
And you're like $10,000 down in service contract.
I'm a cowboy, so none of those machines are on service contract. But that's just Stratus, and it's only because we know them so well. In terms of the SLS space, that's really where we've seen the most growth, and where we're trying to jam as many new machines as we can, as fast as we can. It's one of those things where I don't think it's possible to. First of all, it's super messy. You've got loose powder. You've got many additional machines required for post-processing, so I think this is the same problem that you have with the metal. And just for anybody who's not familiar with SLS, SLS and MJF, sort of categorically the same thing. You might be familiar with either of them, but you have a build platform that fills with a powder, either a laser or heat bolts from the top of the build, sinter the powder together layer by layer. The advantage of this process is that there's no supports required, because as the build descends, the part is being supported by the compacted nylon powder around it. At the end of that process, you take it into a bead blaster, you remove the excess powder, maybe you dye it, you recover some of that powder, you blend it with virgin powder, and then you put it into the next build. So you have loose plastic particulate that's super fine everywhere. You have 2 additional machines. You have an air compressor, maybe you have a nitrogen generator. It's actually kind of incredible that Formlabs has been able to make the Fuse Plus work. So I think it does have some, there's definitely use cases there. But when you're talking about where we see the most work with the SLS stuff is sort of mid to large production runs. So if you need 1,000 parts, you can pack them 2-dimensionally. You're getting very isotropic mechanical properties out of it. You need that big build also, because when you get to smaller builds, you run into thermal management problems. And also when you make those machines smaller and smaller, the heaters that you can fit in them are smaller and smaller. The lasers that you can put in them are cheaper and worse. The galvos are slower. I just think it's not easy to build a machine that does something that complicated cheaply and have it deliver the same kind of result. So I think there's definitely a use case there, but it very much relies on having a high volume of parts. Like some of the volumes that we're seeing now would blow me away when I started printing, because we started really doing prototyping, and I think to tie that back into the original question, how's the industry changed? It's gone from being, or maybe it's just my experience because that's the route that we kind of took, but it went from being we're doing prototypes to we're doing fairly high volumes of end-use production, like over and over and over and over again. Like I might be selling out some of our capacity into July right now. Like these are long production runs.
Yeah.
And sorry, go ahead.
Oh, I was just gonna say, like, I think because I'm an engineer who designs things, but I also kind of run service bureau, right? Like, and from the service part of it, I see the exact same thing. Like less prototyping work and more production work. Because the prototyping is now like everybody can just buy their own machine, right? But from the engineer's perspective, it's like I'm doing more and more prototyping because now I have a machine, right? But anyways, yeah. So I'm seeing the same thing that you.
And I would say that we actually love it when people buy machines. I think when some of these cheaper prosumer machines first started to come out, my first reaction, if I'm honest, was like, oh no, this is going to take away from our business. Like, we've invested in these big machines, and now there's all these really excellent small machines. Like, did I make a bad decision in life? But actually, it turned out that having all of these engineers thinking about 3D printing and designing parts for 3D printing meant that actually they're just going to do way more 3D printing. And when they need an industrial material and they need 1,000 parts, they don't actually want to do it themselves. And we will occasionally get...
You're crazy like me.
But not everybody is failure. I mean, like that's a coveted kind of category. And it does occasionally lead to very funny outcomes, I will say. Like, I had a customer that needed TPU that was run on like a prosumer machine, and they did not want to run like 2,000 parts in that. So can I convince you to use an SLS TPU? It's better, it's more mechanically sound. Like, if they don't want to requalify the part, that's fine. I will buy a wall of Prusas, I will run your parts, and I will flip all of the Prusas. Like, you get occasional humorous outcomes like that. But mostly, from a bureau perspective, the big machines are more efficient at scale. So when you're talking about that kind of volume, the machines last longer, the depreciation costs are better, and they're mostly optimized for materials that are cheaper when you're buying them by the ton.
Right, yeah. And I think, you and I have talked about this a lot, but repeatability is like huge, right? And I'm only starting to step into the world of production, like low volume production, right? I don't do anywhere near as much as you guys, but there's been so many new learnings and unexpected issues that I've encountered going from doing 1 to 10 to 3,000 for Arbutus. It's like thinking about how to pack parts in a box so that things don't stick to the parts or whatever. It's like things you don't think of, and then failure modes that you also don't think of, like with the bamboo lab machines. If I print a lot of ABS, the VOCs and particulates get everywhere and they clog up all the rods in the gantry, and then it just stops working, right? But with the Stratasys machine, that never happens, right? It's just it just chugs along. So I think repeatability is probably a huge one, right?
I will also say that when we got started, we were not paying new unit prices for any of this stuff. I love auctions. equipment for like the price of a couple bamboo machines. Did it need a lot of work to get it going? Yes. Is that a cost savings of about $90,000? Yes. So when I think about some of the mid-range stuff, actually like the $20,000, $30,000 stuff, my thought is always like, well, why don't I just wait for somebody to go bankrupt and buy the like $200,000 machine for like pennies on the dollar? I might need to do some work to it, but I'll get it in at that price point. But you have to be willing to gamble and also suffer. Learn through sadness.
Okay, thanks, Ian. Before we like kind of wrap this up, because I'm already over time, is there any other? Do you guys have any comments about like service bureaus in general? No. Okay. I guess I won't ask you. I guess you can do it quickly. Yeah. Like, what do you want to see happen in 3D printing in the next 2 or 3 years? Like, yeah.
So I think on my end, you know, Gen AI is everywhere. So if there's a way to take advantage of that to give good guidance to students, at least on my end, right? To be able to look at designs and maybe offer some words of wisdom specific to the designs that we're looking at right now. So what are tools that could allow for that kind of input?
I have no idea.
Say for our work, just higher strength materials. I think the rigidity of some of the Formlabs resins have gone really good, but just the strength. Like if we can get 2 to 2.5 times more strength out of 3D printed parts, we would probably delay injection molding for even longer, or maybe not even injection mold, given some of the volumes of our devices. So I'm going to be a happy camper once they come up with a 2 times stronger resin.
I also know real idea. I think having worked on some of the really hard problems in metal 3D printing, I hope that some people will overcome these challenges and can make it work on the lower end. Sort of accomplish what I was saying about the fast turnaround casting style, 3D waterjet kind of style of machine. I was discussing with Phil earlier that my lab actually was running foreign machines before and then decided not to, partly because of sort of resin mess. Anyways, this was before I got there, taking this otherwise, but I'm pretty excited about resin machines and materials and that kind of thing, but I wish that someone were to package it just slightly nicer and to deal with some of the post-processing and solvent turnaround and just deal with some of the hassles in resin printing to kind of get it to the accessibility that FDM is currently at.
Yeah, I echo that. Like, I want to see the industry talk more about post-processing. Because nobody talks about that. It's just like swept under the table, like buy this machine, it'll solve all your problems, and then now you have like 2x problems because you have gallons of IPA that you're like, what do I do with this? How can I recycle it? Yeah, so that's what I want.
There are people standing and their clothes right next to the printer. And
yeah, with like no mask on, like doing SLS with powder everywhere.
I have an entire category of clothes that are just disgusting because I have to wear them around the machines. Also, I realized what I wanted to say for what I'm looking forward to. It's going to be sintering of Peak and Ultim as in a more accessible way. There are machines that do it. I don't have one yet. They're not really super accessible, and the number of people who can service them and install them is kind of small, but hopefully those machines come down in cost because that will be when we can move away from FDM. Well, the tolerances at FDM are hard to beat, but for a lot of applications, stuff that would be Ultim or that would be FDM because you need those high-tech materials could move to a sintered process, which means higher throughput.
Or you just gotta wait for one of those companies to go bankrupt, and then you're good. Okay, that was all the questions. Yeah, I'm around 15 minutes behind.
How do you do that in a medical setting? Isn't there supposed to be any like medical approval for the printed parts, like for cleaning bacteria in like going inside the layers, growth? Just maybe if you can talk more about that.
For sure. So we haven't printed parts that had to be sterilized yet. We want to do that for future products. So the parts that we printed for clinical use were for a class 1 device that had very limited or transient contact with human tissue. And Formlabs actually has all of their processes and materials tested for biocompatibility. So they give you all this data that shows that, and you put that into your risk analysis, and you can say that it's the risk is adequately mitigated because the material is biocompatible. The severity of effect might be low, and the contact is low, etc. So for us, when we do go to using a sterilized, making a sterile device that is more patient contact, and we're going to have to set up some better processes, probably like more dedicated areas, and certainly a dedicated printer that only does that device, those parts. But there's a lot of information out there.
I have a follow-up question. Since you're doing a lot of SLA printing, we have done some SLA printing ourselves, but like out of the printer for a couple of days, the material is good and strong, but when you do longevity testing, it becomes very brittle because of its hygroscopic and then it absorbs moisture. Have you had a problem like that?
So I guess one example is for this add-on that we put on our device, we really wanted to use Biomed Clear because it was stronger, stiffer than Biomed Durable, for example. And we wanted to make the wall sections thinner. But because we weren't as confident in that long-term strength, and because it's a little bit more brittle, and we weren't confident in somebody dropping it. Like let's say they have it on the shelf for half a year and then they drop it on the ground, what happens? So we actually ended up using the Biomed Durable, which was a softer material, but we just beefed up all the wall sections to account for that. And the Biomed, that softer material I can throw across the room over and over again and let it sit in the sun and nothing happens to it. So I guess there's some limitations, but then there's also design workarounds. But then we also paid an arm and a leg because the material was so expensive. So I'm glad we're injection molding it now because we're making 1,000 of those parts a month, 2,000 parts a month. So yeah, it's probably 5 times cheaper to injection mold now.
Okay. Hello, I have a question for the Rapidia folks. So earlier you used the analogy of the application of metal 3D printing for prototype being like a 3-dimensional water jet cutting, and that the metal 3D printing, or at least that experiment, in a couple of commercial applications or commercial ventures has not worked out because the cost has been too high and the reliability has been too low. Well, for water jet cutting, as someone who has spent a lot of time fixing a water jet cutter, the cost is quite high. Like to get a water jet cutter that is actually useful, you're looking at least mid-5 figures. For a good one, you're looking at 6 to somewhere in 6 figures. Yeah, so they're rather expensive, and anyone who's run one knows. Well, it's basically a sandblast cabinet, and so it is constantly eating itself to death, and it needs a lot of work to be fixed. And well, at least in Vancouver, for prototyping applications, it has proven to be quite successful. There are many dozens.
Yeah, well, about
There's there are about a dozen in institutions that work if you maintain them, can you run them. My question is, what decrease in cost and increase in reliability would you have to see in metal 3D printing to be able to capture the same market?
I think it's super hard for me to say on the cost side. That's just a very complicated question. And as things get cheaper, of course, they are easier to justify. I think Phil talked about repeatability. Like that's a little bit different than reliability. Like the machine not breaking down might be considered reliability, whereas repeatability is you get the same part time after time, and you get the part that you expect. Like I think, as Rob was saying, once the water jet machine, like water jet cutters working, you may have some reliability issues with it. We had at Rapidia, we had a water jet cutter, and it did take some maintenance now and then for sure. But once it's running, like you can bang out parts all day long in different thicknesses, and I'd say maybe our experiences differ somewhat, but my experience with the water jet cutter was quite reliable, in the sort of space that you expect it to be. So.
No, when it works, it works. But it still requires a lot of.
Yeah, so I think that's the end there. And honestly, if you've worked with swing sinter parts, it's just not quite there yet. And it's partly this unpredictability of the sintering process, and having to iterate parts around this sort of second design constraint, and also that taking an additional set of time. I think that if you could overcome that, if you could predict it, and if you could get to a point where it worked more like the part you have on the screen is the part you have after the sintering process. And I think that you have some really exciting.
Yeah, that was our experience. Like one part we did for lab automation was if you could get really close to the net shape without and then maybe do some machining, but not have to faff about with like revising the design at all. That is the dream. Because we have that right now with lots of plastic printers, and that was a struggle. I just wanted to say about the medical thing that if you're doing anything that's in the surgical field and it's semi-custom, particularly it's to be one-time use, and then you just X-ray sterilize it. Doesn't matter. You can use FDM, no problem. Which we're doing for. Yeah, you can. No, we're doing it with ABS. What's it called? N2I on a Fortis 450 with Health Canada approval for a big clinical study. That's a FDA approved material, and they seem to be happy with X-ray sterilization. But it's one-time use, so it all gets chucked afterwards. I just wanted to ask Radu, actually, because I was going to ask you about sterile processing earlier, but that kind of got answered. But how far are we from, say, Delrin as a canonical material that we love in terms of the strength issue you were asking about, or you were commenting on? Like you said you wanted the material to get stronger. Is it like, just sort of from my mind, is it like less strong than Delrin or close, or where are we at?
Yeah, so right now, for a lot of our recent devices, they're for holding tension on a pin, and it's like 200 pounds of axial tension that it's got to hold for a duration of time, so there's creep involved as well. We just came up with a finger trimmer. It's trimming your bones in an ED after you've mangled your hand, and it has to be low profile, it has to be sleek, so it has to be the stiffest material, but it's also a single-use device, so it can't be made out of metal, for example. So for right now, what we're using a lot is actually a 60% glass-filled nylon 11. And that's like the craziest material I've ever worked with. It's stiff, it's strong, it's not too hygroscopic, so it's very stable, and it's gamma, you can irradiate with gamma, which is what we predominantly use. So that's 2.5 times stronger than anything I can get from Formlabs. And if I can even get halfway there, but that's molded, yeah. But so if I can get to that point, that would be amazing.
I was just wondering, we talked about the recycling, or I guess getting rid of waste of FDM printing. I was wondering if you think there's going to be anything similar for SLA. Because at least for some resins, Phil is familiar with the part I'm about to talk about, but I was making these 3D printed part models that require a ton of support, probably maybe 70% support by weight. So you buy this $300 resin tank, and then $200 of that would go straight to the garbage because you just throw it out afterwards. I was wondering if you think there's going to be anything, because I guess you can't undo the chemical reaction that was done, but just in terms of if you're using it somehow, or even software to reduce the amount of supports that you need.
So it's funny because I asked for the mic because I thought you were going to ask about recycling IPA, which is something I'm very knowledgeable about, but actually it turns out I know nothing about your question. But I think, as far as I know, Ian, I don't know if you can chime in too, but as far as I know, yeah, there's no way to reverse that chemical reaction. That those supports are just trash. Yeah.
It's basically, if you've got a thermoplastic, you can melt it again and use it again. For photopolymer, it's garbage. And I just wanted to make a quick comment on the earlier question about recycling the filament. The problem is just how cheap virgin plastic is. And also, when you're recycling stuff, really good filament spoolers are really expensive. Like, they're extremely high quality. You're not going to see something that you can put on a desktop that's going to produce filament with a consistent diameter and like a consistent blend. We're just dumping in garbage essentially with God knows what contaminants and God knows what diameter. So unfortunately, short of plastic getting much more expensive, we're not going to see good recycling options for filament.
Yeah, I mean, it's basically the same as why we still have so much plastic waste in the world, right? It's just like cheaper to make new stuff than to otherwise.
Okay, I guess it's me. My question is about localized manufacturing, and with the recent kind of global economy and the southern, the disrespect from the United States, and then we see Mosaic got a tremendous interest, so signaling the intent of a desire for in-house manufacturing or localized manufacturing. Is there an issue kind of stopping Vancouver from becoming a manufacturing hub? And is it based on, is it a marketing thing? Is it an awareness from the producers, from the people who do in-house production? Or is it just a cost issue? That's kind of my main, but for export manufacturing, is it that?
I guess I'll comment first and then you can comment because you look like you want to. Oh, okay. I think there are a lot of parts to it. I think even before like the whole tariff situation, there has been this move, I think, like globally, to start thinking about like on-demand, like onshore manufacturing. And what I've seen, at least for small businesses and companies, is that 3D printers are becoming so cheap now that, politics aside, people are just naturally starting to do onshore, on-demand manufacturing because they can and because it's cost-effective now. I think there are a lot of other factors that like impede or help that are related to like materials. Like we talked a lot about like materials now are getting better to the point where it makes sense to like 3D print something instead of getting something 60% glass filled injection molded. Yeah, but I think like I'm definitely seeing this already, tariffs or not, and I think it's cool. Like I am also being a part of it by like printing stuff for local companies, and yeah, like it definitely, from an engineering perspective and like product development, I think it adds a lot of agility as well. Like there's been more and more times now as an engineer when I'm developing a product where we can just 3D print like 60, 100, 200 parts for beta testing and or like stopgap before and between injection molding. And what that does is it buys you as a company a lot of extra time before you have to lock in your like injection molded design, right? So just, yeah, like I'm definitely seeing it.
I think that timelines for product development and just manufacturing in general are so compressed. Everybody's under so much pressure that that's one of the other things really driving like nearshoring or onshoring or like local manufacturing hubs. If you can get somebody something a day faster, 2 days faster, additive manufacturing as an industry, I feel like is just always the worst deadlines all the time, but it's sort of baked into being a local manufacturer. What's your value versus somebody overseas with less environmental regulations and maybe lower labor costs? It's that you're going to get it there faster. So yeah, I think that it's been growing for a while, but it has a lot to do with the pressure to make things faster and faster.
Oh yeah, so this is like more like a general question to the panel. So today we talked a lot about new horizons, like metal or glass industrial nylon. Just wondering, like, do people think there are any other upcoming new material that you think are promising?
Any other material that's promising?
Are there any other materials in like the 3D printing space that might be coming up that we think is promising? I've been wanting to play with real silicone resin, which is quite interesting. I do a lot of very flexible like 3D prints, and we're at a point now where we can actually 3D print real silicone. It's like 99% real silicone. So that's something that I've been wanting to try. Yeah, I don't know if there's anything very specific. I think similar to what Radu was saying, it's like I just want to see materials with better mechanical properties, right? Like SLA resins that have high impact strength and also high temperature resistance while also being stiff, which doesn't seem like it exists right now. So.
What I'm looking forward to is engineering resins that you can fill a full vat with. So one of the major distinctions between an industrial SLA system and a prosumer system typically is the direction that the parts go in. Like even the very high-end prosumer systems typically pull up out of the vat. The industrial systems typically dip down into the vat. The reason you don't see that implemented on the prosumer systems is you need like $100,000 worth of resin. But the problem also becomes a lot of those engineering resins are not stable over a long enough time for you to cycle through that vat. Like if I fill up a machine with $50,000 worth of resin, I need that resin you need to be able to top that up for like 5 years and just keep refreshing it without it going off. So having resins that can do that and be stable over that kind of time frame and not warp when you print with them, I don't know that we're quite there yet, but there's some new stuff coming out of 3D systems that I'm really interested to see. Yeah.
Also, even if I knew, I don't think I could talk about it anyway. So.
I was going to say, Formlabs is pretty secretive. They told me they're working on some new things, and we want to do some user testing, but they're pretty tight-lipped.
Yeah, so Formlabs is pretty tight-lipped right now with what they're developing, but they're kind of hinting at it or saying, hey, just wait a little bit. So we're trying to get on their kind of user panel to give them feedback. So we'll see.
I do bring samples of silicone and
Awesome. Sorry guys, for hijacking. I'm just trying to keep us on time. So we have a raffle. We're going to try and speed it up for 5 minutes.